2.4, number 17. Determine whether the curve has a tangent at an indicated point. If it does, give its slope. If not, explain why not. So we want to know at 2. This is a line, so we can look at it and know that. Well, first of all, we should figure out if it's continuous. Sorry. And is it smooth or same slope or derivative? If I plug in 2, I get 1/2. If I plug in 2, I get 2/4 or 1/2. Okay, so it's continuous. Let's evaluate their slopes or derivatives. At 2 here, well, actually, we can look at that. This is the same as a line. If I divide them both by 4, so it would be 1 minus 1/4 x. So it has a slope of negative 1/4. So now we need to figure out what the slope of 1 over x is at 2. So we use our difference quotient, which is our definition of derivative. This will tell us our derivative. So for 1 over x, I have 1 over x plus h minus 1 over x over h as h goes to 0. Alright, so we have small fractions, 2 of them inside of one big fraction, so I'm going to multiply the top and bottom by the common denominator of these two fractions, which is x times x plus h. Let me distribute this to here. These x plus h's are going to cross off, divide out, so we get x minus, and then these x's are going to cross off, so it's x plus h. I'm going to leave these in factored form on the bottom so that I can divide off something. So I have x minus h, so it's just negative h on top, and then h over h, so I get negative 1 over x plus h. Now we can plug in 0 for h, so I get negative 1 over x times x, or negative 1 over x squared. So there's my derivative. We want to know the slope at 2, so negative 1 over 2 squared, we get negative 1/4. As you can see, our derivatives are the same. They're both negative 1/4. So the answer to the question, determine whether this curve has a tangent at the indicated point, and you'd say yes. Both the left and the right hand derivatives are negative 1/4.